2.7, addition and subtraction with mixed numbers. Okay, coming in here, we're going to add mixed numbers, subtract mixed numbers by borrowing, and then add and subtract mixed numbers by first changing them to improper, which I'll be honest, I do this a lot, probably more than I need to, but I do that a whole lot. I just go straight to mixed numbers. Okay, to add mixed numbers, add the fraction parts, add the whole numbers, and then write the answer as a mixed number with the fraction part less than 1. Let's come in here and see what they mean. Okay, notice here it gave us kind of a straightforward example. We're going to find the sum of 5 over 2 ninths plus 8 over 5 ninths. Okay, when we come in here, we can write each number as a sum and then use the commutative and associative properties of addition to treat the whole numbers and fractions of parts separately. So notice here, we've got the 5 and the 8s, we've got them all kind of highlighted as green. So when we come in here, notice what's going to happen is we're going to add the whole numbers part. So we got the 5 and the 8 here. We're going to add those separately, and then we add the fractions separately. So when we do this, we get 8 plus 5 is 13. Okay, we've got common denominators here, so we can just do the 5 and the 2. So we got 5 plus 2 is 7, and so our final number here is going to be 13 and 7 ninths. Okay, pretty straightforward. Okay, let's do an example on our own. Okay, so find the sum of 5 and 1/6 plus 2 and 7/18. Okay, well, let's look at these and remember what we just learned. We can go ahead and start grouping things. So if I do the 5s, notice here I get the 5 and the 2. Okay, I've got 5 plus 2. So I'm going to group those. I'm going to put those in parentheses. Plus, well, let's come in here and go, I've got 1/6 plus 1 over 18. Well, let's look here. I've got to find an LCD here, but now instead of doing the prime factorization, I want you to notice something. Notice how this 6, okay, is a multiple, okay, of 18. Well, since it's a multiple of 18, how about I get this 6 and I'll change it to an 18 so that way they match. Well, I know that 6 times 3 is 18. So what I do to the bottom, I have to do to the top. Okay, well, let's continue on as we kind of simplify this. Notice I've got 5 plus 2. That's going to be the 7. I'll go ahead and just do that right now. Plus, now coming in here, I'm going to end up having 3 over 18 plus 1 over 18. Notice now I have a common denominator, so I can just do 3 plus 4. Well, that's going to end up being, let's come over here, 7 and 4 over 18. Well, also notice here, these are both even numbers, so I could come in here and divide everything by 2. Okay, and then my final answer is going to be, well, let's come over here and I've got this 7. Well, 4 divided by 2 is going to give me a 2, and then 18 divided by 2 is going to give me a 9. And so there would be my final answer. Okay, and that's how you would add mixed numbers with different denominators. Let's continue on here, and we're going to work on a perimeter problem. Okay, a triangle has sides measuring 3 1/3, 6 4/5, and 6 over 14/15 meters. Find the perimeter. Remember, perimeter equals distance around. Okay, let's come over here where I've already got it drawn out. Notice they're nice enough here that they already gave us the LCD, which is kind of what I was showing before. Notice that 3 and 5 are all multiples of 15. Okay, I know that 3 times 5 is 15. I also know that 5 times 3 is 15. Okay, and then 15, I don't have to go anywhere with it. So when we're doing perimeter, we can start adding all of these up, and here's what I mean. Well, let's look at our whole numbers here. I've got 3, 6, and 6. So I'll come over here and I'll go 3 plus 6 plus 6, put those in parentheses, plus, big parentheses here, well, I'm going to have 1/3, I'm going to leave myself a little bit of a space, plus 4/5, another little space here, plus 14 over 15. That one I don't need a space for. Notice what I'm trying to do here is this LCD is going to be 15. So how do I make 5 of 15? How about I multiply everything by 3? How do I make 3 15? Let's multiply everything by 5. Remember, the reason I'm doing this on the bottom, I have to do it on the top. Well, let's go ahead and come in here. I've got 6 plus 6 is 12, plus 3, that's going to give me 15, plus, let's come in here with our fractions rewritten. 1 times 5 is 5. And then I know I'm going to have 15 on all the bottoms. 4 times 3 is 12 over 15. And then notice I didn't have to change the 14. Okay? If you want to be exacting, I multiplied everything by 1 there. So I've got 14 plus 12 plus, 14 plus 12 plus 5. And I end up getting 31. Okay, here's where it's going to get a little weird. I've got this 15 plus, okay, notice I'm going to have 31 over 15. I need to change him back to a mixed number. Okay, well, coming over here for this guy, let's look over here. And I'm going to have, how many times will 15 go into 31? Well, that's going to be 2 times. And that's going to give me 30 with a remainder of 1. So, my fraction here, notice I've got a new whole number here now. Okay, which I need to add to the original 15. So now I'm going to have, this 15, okay, plus 2 and 1/15. Well, I can go and just add this whole number right here. Okay, I can just add it straight to it. And that's going to give me 17 1 over 15. And so my perimeter, when it's all said and done, is going to be 17 and 1/15. Don't forget your units. Meters. Okay. Now we're going to subtract mixed numbers, okay? And we're going to subtract the fraction parts and subtract the whole parts, just exactly like we did with addition. Let's come in here and see one that's already filled out for us, and then we'll continue on. Find the difference of 10 and 3/7 minus 6 and 2/7. Notice here, they've got the exact same denominators here, so I can just come in here and go, well, what's 3 minus 2? And what's 10 minus 6? We're grouping. 10 minus 6 is going to be the 4. 3 minus 2 is going to give me the 1. And so my final answer here is going to be 4 and 1/7. If I didn't have an LCD here, I would have to find my LCD. Okay, same process as before. So let's come in here, let's do an example. Find the difference. Okay, they give us this here. Okay, we do not have common denominators. Okay, so I'm going to go and come in here and start grouping. I'm going to go, okay, well, what's 13 minus 7? Grouping, and then I'm going to go ahead and come in here and put the minus sign here, big grouping symbol, and I've got 4/5, okay, minus 1/3. Notice I left myself a little bit of a gap here, and then notice I'm going to leave myself a gap here. Well, these are both primes, okay, so it means on this one they're so small, I know that my least common multiple or my least common denominator is going to be 15. How do I make these a 15? Well, how about multiply this guy by 3 and multiply this guy by 5? Okay, coming in here, I've got 13 minus 7. We'll rewrite that right there. 13 minus 7 minus, well, 4 times 3 is 12 all over 15 minus 5 all over 15. Now we can continue on. Okay, 13 minus 7 is going to be a 6 minus, okay, 12 minus 5, well, 12 minus 5 is going to be 7. And that's going to give us 7 over 15. And so my final answer here is going to be 6, put that there, and 7/15. Okay, you don't see this very much. I mean, you will for your homework. We don't normally write things in that form, so don't get too hung up on this form. I don't even like seeing it in this form, even though we're dealing with whole numbers. I get it, but just doesn't look as nice to me. I like this up here. And to be honest, also what I do with a lot of these, sometimes I go straight to impropers. You can do that as well. It's really up to you. Okay, let's continue on. Okay, if the fraction part being subtracted is larger than the first fraction, procedure: borrow 1 from the first whole number, add this 1 to the first fraction. This will always result in an improper fraction that is larger than the fraction being subtracted. And then we're going to subtract. Okay, what do they mean by that? Let's look at an example. Subtract 7 minus 4 2/3. Okay, in this case, the number 7 has no fraction part, so we must borrow 1 from it. We then write 1 as 3 over 3 so that the denominator will be the same as that of the fraction part of the other number, 2/3. What do they mean by this? Let's look at this as an example. Okay, 7 minus 4 over 2/3. Well, notice this is what they're saying right here. I have this 3 here as a denominator. I don't have anything up here right now. Okay, so they're saying I have to come in here and do this 3 over 3 right here. Okay, once I put this 3 over 3 though, I need to come in here and borrow. Okay, this is what it's saying. Because I'm creating a 1 right here, I need to borrow 1 from it. And then I can come in here and start the subtraction process, which I can do 6 minus 4 is 2, 3 minus 2 is 1, and continue on. Personally speaking, this is one of those situations where sometimes it is easier to go ahead and switch everything to a mixed number and then go on from there. But it's honestly going to be your choosing on if you want to do that. Okay, let's look at an example we'll do. Okay, we're going to do 13 and 5/12 minus 6 over 13 over 20. Okay, and they're going to go ahead and give us the LCD here. The LCD is going to be 60. So let's come here and find out what they're talking about. So let's group our whole numbers. We're going to have 13 minus 6. Okay, minus, okay, I've got 5 over 12 here, minus 13 over 20. Okay, and they're going to say, they're saying our LCD is 60, so 60 divided by 12, okay, gives me, 60 divided by 12 gives me 5. So to get this guy to 60, I need to multiply by 5. To get this guy to 60, I need to multiply by 3. Okay, now I'll continue on. Okay, I've got 13 minus 6 minus, well, 5 times 5, that's going to give me 25. And then I'm going to have the 60 on the bottom, minus, well, 13 times 3 is going to give me 39. All over 60. So rewriting from here, I want you to notice that if I started rewriting, okay, our original equation, if we wrote this vertically, I would end up having 13, okay, and 25 over 60 minus 6, and now I have 39 over 60. Okay, well here, notice what's happened here is I've got 25 on top and 39. What I'm going to do is borrow. By borrowing, I'm going to add on 60 over 60 right here. But once I do that, I have to turn this guy into a 12. And that's now going to give me, and I'll come down here and write this, well, 60 plus 25 is going to give me 85. Okay, over 60, and I can go ahead and keep this 12 there, minus 6 over 39 over 60. Okay, well, now I can subtract 85 from 39, and when I do 85 from 39, I get 23. Okay, so that's going to give me 23 over 60, and then I can do 12 minus 6, and that's just going to give me a 6. And so therefore, my final answer is going to be 6 over 23/60. This does not reduce down any further. And so that's kind of how we do things. But like I said, sometimes in these scenarios, I would probably go straight in here and go, yeah, it's going to make some pretty large numbers that I'm going to have to divide back out to get to my mixed number. But a lot of these, I go straight into the process of changing these into improper fractions, do the math on it so I don't have to worry about all this whole number and borrowing stuff, and then come back in and then put it back into a normal form that I like. So it's genuinely up to you.